what I am saying, on switch number 1, Ethernet 0/0 is configured as dynamic auto, and E0/0 of switch 2 is also configured as dynamic auto. Because of that, operational mode is static access. Static access. So if you want to configure this link as trunk, first of all, let me verify one more thing. So VLAN brief. So here we have some VLANs. So first of all, let me delete these all VLAN, and by default these interfaces are in VLAN 1. So say here no VLAN 2 to, let's say, 100, right? And so VLAN brief. Now we have only VLAN 1 here, and these are default VLAN. Okay, on switch number 2 also, so VLAN brief. So here we don't have any VLAN, only default VLAN are there. Okay, these interfaces are in VLAN 1. So on switch number 1, first of all, let me create one VLAN here, VLAN 10 and VLAN 20. So VLAN 10, let's say name sales exit. VLAN 20 name, let's say marketing exit. Then interface E0/1 switch port access VLAN 10 exit. Interface E0/2 switch port access VLAN 20. Correct. Now so VLAN brief. So you can see this interface is in VLAN 10 and this interface is in VLAN 20. In the same way, let me configure VLAN on switch number 2 also. Host name switch 2, VLAN 10 name sales, VLAN 20 name marketing exit. Interface E0/2 switch port access VLAN 10 and interface E0/3 switch port access VLAN 20. Fine. So VLAN brief. So this interface is in VLAN 10 and this interface is in VLAN 20. Okay, now I am going to down this interface because I will use this interface later. Interface E0/1 say shutdown, and this interface is in VLAN 1. Okay, now if we will assign one IP address on this PC, IP 10.1.1.1/24, and on PC 6 IP 20.1.1.1/24. On PC 7 also let me assign one IP 10.1.1.2/24, and on PC 8 IP 20.1.2/24. Now if you will check communication between VLAN 10 users, like ping 10.1.1.2, that means I am pinging PC 7 from PC 5, right? Both are in VLAN 10. So ping is not working. Why ping is not working? Why ping is not working, guys? Yes.
Two different switches.
So
There is no interconnectivity.
no.
There is no trunk available.
Yes. Link between switches is not configured as trunk. By default, that insert interface is member of VLAN 1. 0/0 of both switch is member of VLAN 1. Okay, so now let me take you to switch 1, and on this switch I'm going to configure E0/0 to trunk. Interface is 0/0 switch port mode trunk. This is command, but what it's saying, command rejected. Why command is rejected, guys? Read the error. Why command is rejected? An interface whose trunk encapsulation is auto
Auto.
can't be configured as trunk, as I told you in yesterday class, right? So first we have to define what switch port
And
trunk
kept
encapsulation protocol, and we
dot
have
one queue.
two protocol. One is .1q and one is ISL. .1q and ISL. So here I will configure .1q, let's say, right? And on now on switch number 2, so interface is 0/0 and switch port. Encapsulation protocol over here is encapsulation protocol over here is
.1q.
.1q. How encapsulation protocol over here is .1q? It have negotiated. It have negotiated encapsulation protocol from switch number 1. See, on other interface like on E0/1, encapsulation protocol over here is also .1q. So maybe in EVNG, on all interfaces by default encapsulation protocol is .1q. But let me do one thing here. Config t interface E0/0 and say no switch port no negotiate. Switch port mode access and switch port no negotiate, do so interface E0/0 switch port. Switch port mode trunk. That's why switching practical should be on rack on real devices. But in my rack, don't know why switch 1 is not working. Because of that, I have to perform lab in EVNG. So here again it's saying encapsulation protocol is .1q. Okay, leave it for a second. See, on switch number 1, I have configured this interface. I have configured encapsulation protocol .1q on E0/0. Right. Interface, let me do one thing. 0/0 switch port trunk encapsulation ISL. And now let me check encapsulation protocol on switch 2. So interface trunk. Interface is 0/0 switch port mode trunk. So interface trunk. Here which encapsulation protocol I am using? ISL. Status is trunking. Native VLAN is VLAN 1. Okay. On switch number 2. So interface is 0/0 switch port. Encapsulation protocol is .1q. So interface trunk. Interface is 0/0 no switch port negotiation. E0/0 shutdown. Interface E0/0 says shutdown. But is not negotiating, right? Switch port, trunk, encapsulation, and say negotiate. And now let me try to check encapsulation protocol here. Hmm. Here we can say negotiate, right? After running this command, this switch should negotiate encapsulation protocol from switch number 1, right? But it's not working. This is definitely problem of simulation software. So interface is 0/0 switch port. So still here encapsulation protocol is .1q and do so interface trunk. There is no trunk port on switch number 2. Mm. So here also, let's say manually, let me define switch port mode trunk, switch port trunk encapsulation ISL, and switch port mode trunk. So interface trunk. Encapsulation protocol is ISL and the status is trunking. Now PC5 can ping to PC7. Now I ping is not working then. So spanning. Ping will definitely work now. PC1 is not able to resolve MAC address of 10.2. PC1 is not able to resolve MAC address of PC2, PC7. I mean PC7. On switch number 1 we can check MAC address table. So MAC address table, and see in GNS3 or in UNG you will not see any static entry here, right? You will not see any static entry. So this switch have learned one MAC address on 0/0. I think this is MAC address of PC7 and this is MAC address of PC5, right? Switch, everything is correct here on switch number 2. So VLAN brief E0/2, E0/2 is member of VLAN 10. Here also it's fine. And on switch 2, so MAC address table. Inside the MAC address table, we have one MAC address on 0/0. Actually, we have two MAC address on 0/0 and one MAC address on 0/2. So here it's, here also MAC address table look like fine, right? Mm,
Why we have the two MAC address on that same port 0/0 in switch 2?
maybe one MAC address of PC5 and one MAC address of PC6.
Oh, okay.
When you will assign IP address, definitely it will generate what? Gracious ARP.
Yes, yes, yes.
Gracious ARP is broadcast. So switch 2 will learn MAC address of PC6. Yes or no?
Yes, yes, yeah.
So VLAN 20 users are able to ping each other, right? So on PC number 5, so 10.1, this is correct. On PC number 7,
Do we
10.
need to configure E0/1 0/2 access port on
0
switch
slash
1?
1, yeah,
And
this port is access port na. On switch 1 this port is access port, so VLAN brief. 0/1 is access port for VLAN 10 and this port is access port for VLAN 20. PC7 is able to ping PC5. What is this? Ping 10.1.1.2. Yes, now ping is working. Don't know why ping was not working earlier. Right now ping is working, and in the capturing you can see ICMP packet. So if you will open any ICMP packet here, this is ICMP packet, this is IP, v4 header, and this is tagging. In tag VLAN ID is 10. This is .1q header. So .1q encapsulation protocols will add these information, these extra information, right, on the trunk link.
Actually, how it took that 10, that VLAN tagging?
So
It will take that random number.
not
How it is?
random number. This interface is in VLAN 10 and switch is receiving ICMP packet on this interface, which is member of VLAN 10. So same switch is going to forward ICMP packet from the trunk link, so it will add tag number. .1q protocol will add tag number with frame.
Okay, same VLAN number.
Right.
Okay.
And this is how switch 2 will came to know that this is a frame of VLAN 10. Then only switch 2 can forward it from this interface, na 0/2. Yes or no? Which is member of
Yes,
same VLAN.
yes, yes. Yeah.
Right. But guys, here some feature is not working. Like on switch number 1, if I have defined encapsulation protocol .1q, switch 2 can automatic negotiate that. Switch 2 can automatic negotiate that. And after that, so interface trunk, if you will run this command, so interface trunk, you will see sometime here you will see n. N means negotiation. Whenever switch will configure encapsulation protocol dot one q from negotiation, in that time you will see n there, right? So trunking can be also configured from the negotiation, and encapsulation protocol can be also configured from the negotiation. Let me try one more time for negotiation. Like on switch number 1, this time I am going to say interface is 0/0 and switch port trunk encapsulation negotiate. Command is rejected because this interface is configured as trunk. So let's say switch port mode trunk. Let me remove this command from here, and switch port trunk encapsulation dot one q. Let me remove this command also from here, and now switch port trunk encapsulation negotiate. So interface is 0/0 switch port. Encapsulation protocol is showing what dot one q. So interface trunk. Now you can see n symbol here. That means this time the switch is configure encapsulation protocol dot one q from negotiation. Okay. Now on switch number 2, if I will change encapsulation protocol, switch port trunk encapsulation ISL. So automatically switch 1 will also change their encapsulation protocol. So interface trunk on switch number C. These are problem of guys simulation software. So interface trunk, here encapsulation protocol is ISL, and on switch number 1 encapsulation protocol is dot one q. Let me set the interface and let me run no set again. Set and no set. So interface trunk. So interface is 0/0 switch port. Right, it is not negotiating right quickly, but it should. On real devices, quickly it will set their interface as trunk by using encapsulation protocol ISL. Now on both sides, let me configure encapsulation protocol dot one q manually is 0/0 switch port trunk encapsulation protocol dot one q, and on switch number 2 also say interface is 0/0 switch port trunk encapsulation dot one q. So interface trunk. So this interface is E0/0 is configured as trunk on switch number 1. Do so interface trunk. So here we don't have trunk. Switch port mode trunk. And interface E0/0 switch port mode trunk. This is manual configuration. Right, manually both side I have run switch port mode trunk command. So interface trunk. There is no n on switch number 1 also. So interface trunk. Done. Now with the help of DTP protocol, how we will configure trunk. With the help of DTP protocol, how we will configure trunk. So let me remove this command interface is 0/0. Say no switch port mode trunk. No switch port mode trunk, and on switch number 2 also say no switch port mode trunk on E0/0. Say no switch port mode trunk. No switch port mode trunk. This interface is configured as access or trunk mode manually. So no switch port. Yes.
Switch port X encapsulation negotiate. I think first we have to configure that non-negotiate.
No, these are problem of simulation software. Now to enable dynamic trunking protocol, DTP protocol, what I will do? To enable DTP protocol, what I will do, on both switch I will configure switch port mode, either dynamic auto or dynamic desirable. So switch port mode dynamic auto, let's say, right? This command will enable DTP on this interface, and mode is dynamic auto. On switch number 2 also, switch port mode, switch port mode dynamic auto, right? So we will not have trunking, but on switch number 1, do so run interface is 0/0. Let me remove this command. Okay, so you can verify it. So interface trunk, we don't have trunk interface on switch number 1. In the same way, we don't have trunk port on switch number 2. So interface trunk. So I want to form trunking with the help of DTP protocol. Either I can set dynamic port mode to dynamic auto on switch number 1 or on switch number 2. Automatically it will form trunking. So let me set dynamic auto on switch number 1. Interface is 0/0. Say switch port mode dynamic desirable, not auto, dynamic desirable, right? And do so interface trunk. So this interface is configured as trunk. Encapsulation protocol is ISL. How? With the help of negotiation. With the help of negotiation. On switch number 2 also, so interface trunk. Encapsulation protocol is ISL with the
అమ్మమ్మ
help
వాడికి
of
తులసి వాటర్
negotiation.
పోసి అమ్మమ్మ
And the status is trunking.
తెలియదు ఇంకా
Status is trunking. So this is DTP protocol. Okay, if I will say .1q on one switch, let's say on switch number 2, interface is 0/0. Switch port trunk encapsulation .1q, Now you can verify encapsulation protocol on switch number 1. Here also you can see encapsulation protocol is now what? .1q with the help of negotiation. And on switch number 2, if you will then show interface trunk command now, do so interface trunk. So you can see here n is not showing, right? Because here manually I have defined encapsulation protocol .1q. And mode on this switch is auto, and mode on switch number 1 is desirable. Because of that we have trunking between switch 1 and switch 2. Now again PC5 can communicate with PC6 because trunk is working fine. Okay, clear guys? Tell me, any question? Tomorrow I will troubleshoot my rack, right? Okay, if I will resolve the problem, then definitely I will show you this configuration on real devices as well.
Okay, actually for that manual configuration for this trunk, we should have that mode at that both end,
Both end we need to run command switch port mode trunk.
no, that is okay. That mode I am saying it should be
Mode
on
will
and end.
mode will be static access, static trunk. Mode will be static trunk. When we are running command switch port mode trunk, right? Manually we are defining what? Mode trunk.
Yeah,
So that
yeah,
is manual configuration. Mode will be trunk.
yeah. One side should be mode auto and another side should be mode on, right? But
In
it's
a
showing
static, both side mode will be trunk.
no. If we see that old logs, it's showing that mode on something, and another side it's showing that auto.
No, see here, if I will run switch port mode trunk, switch port mode trunk, switch port trunk encapsulation dot 1q, and switch port mode trunk on switch number 1, also interface E0/0 switch port trunk encapsulation dot 1q and switch port mode trunk, and now show interface trunk. So mode is on. Okay, in a static mode will be on.
Means one side we have that auto and another side we have that
No,
on.
both side on. On switch number 1 also mode is on, and on switch number 2 also mode is on.
No, auto is there. You can see.
Hmm? Okay, this side mode is auto.
Yes, yes. Actually, one side should be auto and another side should be on, or otherwise that both sides should be on. Then
Here I
only
have run this command switch port mode trunk. Both side mode will be on na, in a static.
I think non-negotiation is there, no? So that's why.
No, if we are running command switch port mode trunk both side, then mode will be on both side na.
Okay.
Switches is not going to negotiate this time.
If suppose negotiation is enabled means
If I have disabled, if I will remove this command from here, no switch port mode trunk, and do so interface trunk, then mode will be what? Auto. That means this switch have negotiated trunking from switch 1.
okay, okay.
Again it's working using DTP protocol, dynamic trunking protocol.
Yes, in the dynamic, I think one side should be desirable and another should be like
In
auto.
DTP, one side should be desirable and one side should be auto.
Auto. Okay. If both side the desirable means it
Both side desirable will be also work fine.
fine. Okay.
Right? Desirable and desirable can form trunking.
Okay. Okay.
Now on this trunk link, how many VLANs are allowed? All VLAN are allowed, yes or no? And how many VLAN are active? Means how many VLAN are there in management domain? VLAN 1, 10 and 20. VLAN 1, 10 and 20. If you want to remove some VLAN from the trunk link, means you don't want to allow some VLAN on trunk link, so you can remove some VLAN as well from the trunk link. Okay, on this interface.
But default VLAN we cannot remove, na?
Default
VLAN
VLAN,
1.
no, default VLAN can't be removed. Interface is 0/0, switch port, trunk, allowed, VLAN. And let's say VLAN remove 20. Do so interface trunk. So VLAN 1 to 19 and 21 to 4094. These VLAN are allowed on this interface. Okay, so now VLAN 20 user cannot communicate because VLAN 20 traffics are not allowed on this trunk link. So I will remove this command. Okay guys, clear? Is it clear? DTP protocol.
How to allow 10 and 20 only through the trunk link?
Only VLAN 10 or 20.
Uh,
Switch port, trunk, allowed, VLAN 10 and 20. Do so interface trunk. Okay.
if you want to allow one more VLAN, 30 now.
Okay. Any other question? Fine. Clear guys? DTP protocol. Yesterday we discussed theory part, today we discussed practical part. Okay.
Yes, yes.
Now next protocol is VTP, VLAN trunking protocol. See, VLAN is okay. Next protocol is VTP. See, in this scenario, I have switch 1, switch 2, switch 3, switch 4, right? Let's say I need to create 10 number of VLAN, right? Then I need to run 40 command. I will run 10, I will create 10 VLAN on switch 1 also, switch 2 also, switch 3 also, switch 4 also. So that's why we come up with VTP protocol. So what is VTP protocol? VTP protocol is used to propagate or advertise VLAN information between switches. VTP protocol is used to advertise VLAN information between switches. or first I should discuss inter-VLAN routing, then I will move to VTP protocol. Now question is how to make communication possible between two different VLAN. Let's say I have a switch here and I have two user, two PCs. Very simple topology. See, what is recommendation? You should use different subnet for different VLAN, right? Why? Because if you will use same subnet for, let's say, different VLAN, then you cannot perform inter-VLAN routing. Then you cannot perform inter-VLAN routing. In this scenario, let's say this is my PC1, this is PC2. PC1 is in VLAN 10, this PC is in VLAN 10, and this PC is in VLAN 20. So if I want to make communication possible between VLAN 10 and 20, I should use different subnet for both VLAN. Like let's say here I am using subnet 10.1.1.0/24, and here for this VLAN we are using 20.1.1.0/24, this subnet, right? Now in this scenario I can achieve inter-VLAN routing, but here also let's say if I will use same subnet 10.1.1.0/24, then I can not achieve inter-VLAN routing. Let's say PC1 IP address is 10.1 and PC2 IP address is 10.2. Now PC1 cannot communicate with PC2. PC1 can never communicate with PC2. We cannot achieve inter-VLAN routing. So if you want to perform inter-VLAN routing, and this is recommendation guys, whenever we have different VLAN, you should use different subnet. One subnet for one VLAN. So let's say here IP address of PC1 is 10.1 and IP address of PC2 is 20.1. Right, in VLAN 20 we are using this subnet 20.1.1.0/24, right? So for inter-VLAN routing we have two methods, we have two options. First option is we need one multi-layer switch. With the help of multi-layer switch we can achieve inter-VLAN routing by using method called SVI. Okay, switch virtual interface. And second method is a router on a stick. I can use a router on a stick, this method. Okay, so you tell me first of all which method you want to discuss, SVI or router on a stick. In router on a stick we will use one router, right? In SVI we will use multi-layer switch. So let's say this is multi-layer switch. Simply what you need to do in in first method, simply you need to configure one IP address on VLAN 10 interface. Let's say I will create one VLAN 10, and on interface VLAN 10 I will assign IP address 10.1.1. Let's say 100, right? 255.255.255.0. Then interface VLAN 20, and on this interface also I will assign one IP address 20.1.1.100, 255.255.255.0. okay, and for PC1 default gateway will be 10.100 and for PC2 default gateway will be 20.100. Now PC1 can communicate with PC2. Why? Because router will start maintaining a routing table. This is multi-layer switch. On multi-layer switch we can perform routing also, right? So this router will start maintaining a routing table. In their routing table there will be two entry, right? There are two directly connected network. Directly connected network is denoted with C. 10.1.1.0/24 is connected on which interface? VLAN 10. And C 20.1.1.0/24 is connected on which VLAN? VLAN 20. So when PC1 will ping 20.1, see, when PC1 will ping to PC2, source IP will be 10.1.1.1. Destination IP will be 20.1.1.1. Right. Source MAC will be MAC address of PC1, let's say A. Destination MAC will be MAC address of PCB, let's say B. Right. Now this PC not B. Destination MAC will be not B. Destination MAC will be what? MAC address of default gateway na. Source IP 10.1.1.1, destination IP 20.1.1.1, because whenever PC need to forward traffic in different network, destination MAC will be MAC address of default gateway. So source MAC will be PC1 and destination MAC will be the MAC address of interface VLAN 10. VLAN 10, right? PC will forward this packet to the default gateway to switch. Switch will receive it on this interface. Let's say this is 0/1, which is member of which VLAN 10, which is member of VLAN 10. First of all, switch will check destination MAC. Destination MAC is the MAC address of my interface, VLAN 10 interface. Then switch will check what? Destination IP address 20.1.1.1. For this network, switch is going to check their routing table. In their routing table, one entry is there for 20 network, which is connected on which interface? VLAN 20. So switch will forward this packet from this interface, which is member of VLAN 20. Right. In the packet, source will be the MAC address of VLAN 20 interface and destination will be MAC address of PC2. This is how PC1 and PC2 can communicate with each other. Done. Clear? Here you can see PC1 IP address is 10.1, PC2 IP address is 20.1. Simply on switch number 1, what I can do to make communication possible, I can create one SVI interface VLAN 10 and IP address 10.1.1. Let's say 100.255.255.255.0, say no set. Then I will create one SVI for VLAN 20 also, interface VLAN 20, no set, and IP address 20.1.1. 20.1.1.100.255.255.255.0. Done. So IP route, you can see the routing table of the switch, and now PC1 can ping, PC5 can ping to PC6, that means to VLAN 20 user. Ping. First of all, let me ping the gateway. So yes, definitely it will not ping until and unless we will not define default gateway. So let me define default gateway 10.1.1.1/24 and gateway IP address is 10.1.1.100. On PC6 also I have to define default gateway. IP 20.1.1.1/24 and 20.1.1.100. Right. Now let me ping my gateway. Ping 10.1.1.100. See, I'm able to ping my gateway, and let me ping 20.1 as well from here. Ping 20.1.1.1. So see, ping is working. Okay. First method. Second method is a router on a stick. You have to use one router. See, again, scenario is same. I have one switch. I have one PC here. Have another PC in VLAN 20. This is in VLAN 10. PC2. Switch. Let's say one.
Sir, the switch has the command IP routing.
Yeah, you have to put IP routing command, but that command is already enabled here. Definitely you have to enable routing, right? By default on multi-layer switch, routing is disabled. Routing will be disabled on multi-layer switch by default. So you have to run IP routing command. IP routing to enable routing.
Oh, you have given that command before, or
In the EVNG it's not required.
okay.
Okay, let's say this is 0/2. Fine. Again, this PC IP address is 10.1.1.1. This PC IP address is 20.1.1.1. Okay, this interface is in VLAN 10. This interface is in VLAN 20. Here, let's say this is layer 2 switch. This is layer 2 switch. So on layer 2 switch, we cannot create SVI, right? We cannot run this command interface VLAN 10 and IP address. This one we can assign IP address only on VLAN 1 interface at layer 2 switch for the management purpose, to access that switch remotely through telnet or SSH, right? For those purposes. So let's say this is layer 2 switch. Then how I can achieve communication between VLAN 10 and VLAN 20? So you have to use one router here. Okay, so let me use one router. Let's say this is router, and I need to connect this router to this switch. Okay, let's say this is F0/0, right? So guys, in this scenario, first of all, you have to configure this interface as trunk. This interface should be trunk, because this interface is going to carry traffic of VLAN 10 also and VLAN 20 also, right? This interface is going to carry traffic of VLAN 10 also and VLAN 20 also. So this interface should be trunk. So let's say this interface is trunk, and encapsulation protocol is dot 1Q. Encapsulation protocol is dot 1Q. Okay, now on router, you know how many interfaces we have? Only one, which is connected with switch. And how many VLAN we have? Two number of VLAN, right? So I need actually two interface on this router, one for VLAN 10 and one for VLAN 20. So what we can do, we can divide this one physical interface into two logical interface. I can divide this one physical interface into two logical interface. So let's say I have divided this physical interfaces into two logical interface. One is 0/0.10 and another one is 0/0.20, right? After that, on logical interface, on this virtual interface, we can define encapsulation protocol. So here we will define encapsulation protocol dot 1Q for which VLAN? For VLAN 10, we will define encapsulation protocol dot 1Q, right? On this interface, we will define encapsulation protocol dot 1Q for VLAN 20, right? And after that, here I can configure IP address as well. So let's say here IP address is 10.100, here IP address is 20.100. Now VLAN 10 user can communicate with VLAN 20 user. Now VLAN 10 user can communicate with VLAN 20 user. How guys? I will define default gateway on PC1. Default gateway is 10.100. On PC2, default gateway is going to be 20.100. So whenever PC1 need to communicate with PC2, source IP 10.1, destination IP 20.1. Source MAC address of PC1, destination MAC address of default gateway, right? MAC address of 0/0.10, right? PC1 will forward packet to their default gateway to router number 1. First it will forward to switch. Switch will receive it on this interface. Switch will check receiving interface is member of which VLAN? VLAN 10. So it will forward the frame from trunk link, right? It will check destination MAC. So destination, definitely switch will learn MAC address of this virtual interface on this trunk link, right? So it will forward the packet from this interface. When router will receive it, router will receive on which interface? Will switch perform tagging? Definitely yes. Switch will add tag number for VLAN 10. So when switch will receive it, right, it will first check tag is 10, that means it is traffic of VLAN 10. So router interface will hand over it to this interface, to this virtual interface, where I have configured encapsulation protocol .1q for VLAN 10. Right, again switch router have routing table, it will check their routing table. In their routing table, destination is 20, so for 20 exit interface is this one, 0/0.20, so it will forward the traffic from 0/0.20. Getting my point? Is it clear? Any question? Should I perform lab of this, guys? Because it is very easy, you guys can perform lab by yourself also.
The router has different MAC for .10 and .20.
Yes, definitely. Router will have different MAC address for this interface and this interface. Do you guys want lab
Yes,
on
sir.
router stick? Yes. Okay, then let me perform it. Okay. On switch number 1, no interface VLAN 10 and no interface VLAN 20 and no IP routing. Interface VLAN 10, IP address 10.1.1.1 exit, sorry, interface VLAN 10 and say no set, and so IP route. Okay, so layer 2 switch will work like this. Okay, so now let me remove interface VLAN 10 from here, say no to this. Right, again if you will verify communication between PC 5 and 6, you can see it will not work, ping will not work. Done. Now let me connect one router here. Interface E0/1 switch port access VLAN 10, exit interface E0/2 switch port access VLAN 20. Then interface E0/3, this interface should be trunk, so switch port trunk encapsulation .1q and switch port mode trunk. Done. Switch configuration is done. No, we don't need to configure anything on switch. Now let me take you to router 1. On this router, say no. On physical interface, simply I will run no set command only. I will run no set command only on physical interface. No sir. Done. Then interface f0/0 dot 10 encapsulation dot 1q for which VLAN? For VLAN 10, and then IP address 10.1.1.100 255.255.255.0 and say no sir. Exit. Interface f0/0 dot 20 encapsulation dot 1q for VLAN 20 and IP address
Sir,
20.1. Yeah.
that interface dot 20 and encapsulation dot 20 should be same or can be different? We can give different interface number. Dot 2 also works.
No. Yes. Dot 2 can be, this can be anything, right? Encapsulation protocol can be anything, right?
But this should be dot 1 Q should be 20. That number, interface number can be anything. Sub
Right.
interface number.
Interface f0/0 dot 1 encapsulation dot 1q for VLAN 10 IP address 10.1.1.1 255.255.255.0 IP address is not 100. Exit. Interface f0/0 dot 2 encapsulation dot 1q for VLAN 20 IP address 20.1.1.100 255.255.255.0 encapsulation protocol on switch like on trunk interface and on this sub interface virtual interface should be same. If here you will configure encapsulation protocol ISL and on switch encapsulation protocol is running, let's say .1q, then it will not work. Okay, so IP route done. Now you can check the communication from PC5 to PC6. Okay, it's working. So we have two methods for inter-VLAN routing. We can use any one, depends on scenario. Any question?
So we can create sub interfaces. That is the one method. Second one.
Second one is SVI. On multi-layer switch, you can create SVI interface, switch virtual interface.
Okay. Multi-layer switch, that is okay, but L2 switch.
On
Only
L2
one
switch,
method.
you cannot create SVI, na? So that's why we have router on a stick. For L2 switch,
Okay.
we have router on a stick. Now, guys, let me ask you some question here. Here between switch 1 and switch 2, link is trunk or not? Let me verify it. The switch 1. So interface.
Why it's
Trunk.
showing host not reachable, that gateway not reachable?
Where? Where?
10.1.1.
Ping is working na?
Ping is working, but it's showing.
Where it's showing? Where it's showing? In the console of which device? Where is host unreachable? I'm not able to see. Yes, Dana.
You can scroll up.
Oh, so earlier it was not
Some-
working na? Ping was not working na at layer 2.
Okay.
This one?
Yes.
So this is, earlier output, not now. Now ping is working, right? Through router on a stick. Now let me configure link between switch 1 and switch 2 as trunk. So on switch number 1, config T, interface E0/0, switch port, mode, dynamic, desirable. So interface trunk. Okay. Now on switch number 2 also we have some user in VLAN 10 and we have some user in VLAN 20. So let me assign default gateway to PC7 and PC8 also. To PC7 IP 10.1.1.2/24 and 10.1.1.100. To PC8 IP 10.1.1 sorry 20.1.1.2. On PC7 I have assigned which IP address? 10.2, correct. Here 20.2/24 and 20.1.1.100. Right, now PC5 can ping PC7 also, PC8 also, right? So from PC number 5, let me verify the connectivity. Ping 20.1.1.2. So I'm able to ping PC8 also, right? I'm able to ping PC8. And now link between switch 2 and switch 3, let me configure this link also as trunk. So simply on switch number 2 or on switch number 3, let me configure trunk link between switch 3 and switch 4 also. So go to switch number 3, let me access switch 3, and here I am going to run switch port mode dynamic desirable. Interface range E0/0 as well as E0/1. Switch port mode dynamic desirable, right? It will form trunking between switch 2 and switch 3 as well as between switch 3 and switch 4. Now on switch 4 I have one user in VLAN 30. Let me assign one IP address to this user. IP 30.1.1.1/24 and gateway is, let's say, 30.1.1.100. Right, now can 10.1 ping 30.1? No. For
No, no.
this I have to create one more virtual interface on router. Yes or no?
Yes.
So let me take you to our router, and in this router I am going to create one more virtual interface. Interface F0/0.3. Encapsulation.1Q for VLAN 30 this time, and IP address 30.1.1.1 255.255.255.0, not 100. Right, now okay, now can 10.1 ping to 30.1? Can 10.1 ping 30.1? First of all, let me ping 30.1.1.100. I'm able to ping gateway of VLAN 30, but can I ping 30.1? Ping is not working, guys, and now tell me the reason why this ping is not working.
I think in that trunk mode we have only VLAN 1, right?
On trunk link we have only VLAN 1.
Switch 1.
Switch 1. So interface trunk. So all VLAN are allowed on both trunk port. On both trunk port, all VLAN are allowed. So VLAN brief. This is VLAN output. Problem is what? Oh, on switch number 4, I think I have not assigned this interface in VLAN 30.
Yes.
Let me do one thing. Then also ping will not work, by the way. So VLAN brief. Okay, so let me create VLAN 30 exit interface E0/1 switch port access VLAN 30. Now also you can see from PC5 I'm not able to ping 30.1.
VLAN 30 should be on all the switches, right?
Yes, VLAN 30 should be on all switches, VLAN 10 should be on all switches, and VLAN 20 should be on all switches. Right. So for this, what I can do on switch number 1, where is my switch 1? So VTP status config t VTP domain name CCNA. So VTP status on switch number 2. So VTP status here also domain name is here CCIE. VTP domain name CCNA. So VTP status. Okay, let me check VLAN is working fine between switch 1 and switch 2 or not. So for that, here I am going to create one VLAN 100 exit. Let me check that VLAN is available on switch 2 or not. So VLAN brief. So VLAN 100 is not here. So interface trunk 0/0 between switch 2 and switch 3. Y link is access. Oh, this interface is down. Interface is 0/1. Again, here it's using ISL protocol.
Some error message is showing it, right? Some
Where?
dynamic variable.
Where? On switch 3?
Switch to.
No. So VTP status, VTP mode. Okay, let me create VLAN 30 manually here on switch number 2. Done. And on switch number 3, I need to create VLAN 10, VLAN 10, VLAN 20, as well as VLAN 30. Right. On switch number 4 also, I need to create VLAN 10, VLAN
Yes.
10. Yes.
VTP domain mismatch.
Yes. Don't worry about that message. right? I have created VLAN 10, 20, 30 on all switches. And now if you will check connectivity from PC5 to 30.1, now ping will work. Ping should work now. From PC9, let me ping gateway, ping 30.1.1.100. On switch 4, so interface trunk, so E0/0, interface E0/0 switch port trunk encapsulation.1q. Switch port mode dynamic desirable. Still trunk is not there, right? Okay, let me verify switch 3. So interface trunk, this is router. E0/0 is trunk, but E0/1 is no trunk. Interface E0/1 and switch port. This interface mode is static access operational mode, and administrative mode is dynamic desirable. So dynamic desirable, then operational mode should be trunk, no? These are problem of, guys, simulation software, right? Here you can see between switch 3 and switch 4, right, link is not trunk, right, but both interfaces configured as dynamic desirable. Both interfaces are configured as
Configure
dynamic or
everything
yes,
trunk, not dynamic desirable. If you configure
dynamic
everything
desirable.
trunk,
Yeah, definitely. Then trunk, let me do this also manually. That is manual configuration 0/0 switch port mode trunk. Now so interface trunk. Now this interface is trunk. Encapsulation protocol is .1q. On switch number 3 also, let me configure a static trunk. Interface E0/1 switch port mode trunk and switch port trunk encapsulation.1q. So interface trunk. Now both interface are trunk. Okay. On switch number 2 also, let me verify it. Both interfaces are trunk or not. So interface trunk. Okay. Done. Now let me ping to gateway of PC9. Wait topology will take 30 seconds, to come in forwarding state. After 30 seconds, I think ping should work. So IP all 30.1. Okay. On switch 4, so VLAN brief. So VLAN brief. So this interface is in VLAN 30. Okay. E0/1, correct, and these two interfaces are in VLAN 1. So interface trunk here. Okay, this interface is configured as trunk. Okay, on switch 4 we don't have any problem. Then ping should work here. Ping 30.1.1.100.
can you check whether the trunk link think of switch 1, 2, 3 allows VLAN 30.
Yes, all switches allowing VLAN 30. By default, so interface trunk. By default, all VLANs are allowed. Only here on switch number 1 we have manually allowed these VLAN, these 3 VLAN only, these 4 VLANs. So ping should work, but ping is not working. So on switch 2 everything look like fine. Interface trunk, and so VLAN brief, VLAN 30 is exist. On switch number 1 VLAN 30 is there or not? So VLAN brief, yeah, on switch number 1 VLAN 30 is not there, so VLAN 30. And now from PC9, let me try to ping gateway again.
On switch 3.
So VLAN brief, so VLAN 30 exists now, yes.
Yes.
And so interface trunk, so both interfaces configured as trunk by using .1q encapsulation protocol. Okay, it's fine here. Okay, now ping is, you can see working, right? And now PC5 can also ping, means 10.1 can also ping 30.1. Ping 30.1.1.1, you can see ping is working now. Because of a spanning tree protocol, topology will take 30 seconds to converge, right? Maybe because of that ping was not working. Earlier there was some problem, right? We don't have VLAN 30 on switch number 3, 2 and 1, and on all switches we need VLAN 10, 20 and 30, right, for communication. So this is router on a stick. This is router on a stick method for inter-VLAN communication. Now see, in this scenario my broadcast domain is small and still we are able to communicate with each other. So sometimes people think if we divide, we stop communication by creating VLAN, right, then why I will make communication again between two VLAN. So with the help of VLAN, just I have divided broadcast domain, and again with the help of inter-VLAN routing we had done the communication between inter-VLAN. Getting my point, guys?
Can you check VTP now? VTP works now.
No, you know why VTP is not working? Because in VTP we have some modes, right? In this scenario VTP is already configured. VTP is already configured, and on some switches mode is off, on some switches mode is transparent. That is the reason why VTP is not working. On all switches, if I will change VTP mode to server, definitely VTP will work fine. Let me show you. From switch 1, let me close the console of router. PC5, PC6, PC7, PC9. Now again come to topology. Switch 1, VTP mode server. Okay, this device is already in server mode. VTP mode server. So setting device to VTP mode server for VLANs. Okay, on switch number 3 On switch 3 I did. Okay, on switch 2 VTP mode server. So setting to VTP mode server. Okay, fine. Then go to switch 4, config T, VTP mode server. Now on, let's say on switch number 4 I am going to create some VLAN. Before that, let me verify. So VTP status, here VTP domain name is CCI. So let me configure same VTP name, VTP domain name CCNA. On switch number 1, what is VTP domain name? So VTP status, VTP domain name over here is CCNA. On switch number 3, so VTP status CCNA. And on switch 2, so VTP status, here also VTP domain name is this one. Okay, now on switch 1 I'm going to create one VLAN. Let's say VLAN 105. So VLAN brief. Okay, VLAN 105 is created over here. On switch number 2, so VLAN brief. So VLAN 105 is automatically created on switch number 2 also. Go to switch number 3. So VLAN brief. VLAN 105 is automatic created on switch number 3 also. Go to switch number 4. So VLAN brief. VLAN 105 is automatically created over here, right? If I am creating any VLAN, let's say VLAN 6 exit, VLAN 7 exit, VLAN 8 exit, VLAN 9 exit. So VLAN brief, right? VLAN 6, 7, 8, 9 is created on switch number 4. On switch number 3 also you can verify. See, on switch number 3 also automatically VLAN 6, 7, 8, 9 created, right? On switch number 2 also you can verify. See, VLAN 6, 7, 8, 9 automatically created. On switch number 1 also you can verify it, right? So now VTP is working fine. Actually earlier VTP was pre-configured there, right? On some switches mode was off, right? On some switches mode was transparent, on some switches mode was server, and on one switch mode was client. Done. So I have covered VTP also. So you can see, guys, with the help of VTP how switches are propagating VLAN information. This is VTP protocol.
Praful,
Yeah,
here switch 1, switch 2, switch 3, switch 4 are all having all VLAN interfaces, VLAN 10, 20, 30.
correct.
Without creating, for example, my switch 1 having the 20 VLANs. Number of VLANs count is 20. Switch 2
Okay.
having the 30. Switch 3 roughly 10 and switch 4 having the 40. So if you want to communicate to each other, we have to configure all VLANs into switch 1, switch 2, switch 3,
Yes,
switch 4.
correct. Yes.
But
Reason
here
is,
utilization is more now.
why CPU utilization will be more? By creating VLAN, see, until and unless VLAN will be not there in the database of switch. Let's say on switch number 3, VLAN 30 not exist, right? So when switch 2 will forward any traffic of VLAN 30, it will add tag number 30, and switch 3 cannot understand VLAN 30, because VLAN 30 does not exist over here. So when switch 3 will receive it on on this interface, it will check tag number. In tag, VLAN ID is 30. But if VLAN 30 is not in the database of switch 3 is not going to process that traffic. Switch 3 is going to discard that traffic. So because of that, we need all VLAN on all switches. And now these all switches are in single VTP domain, right? So whatever VLAN you will create on one switch, automatically that VLAN will be propagated to all switches.
And one more, if switch have the VLAN 20 and VLAN 30, I want to communicate with the VLAN 20 from the switch 1 VLAN 20.
One on switch number 1, you have one user in VLAN 20, right?
Yes.
Okay, on switch number 2,
We have the user on VLAN 20, and switch number 4
okay,
also we have the VLAN 20 user.
20. Okay,
I want to communicate with the switch number 4 user in
okay.
VLAN 20.
Yes, he can communicate.
So what it will carry from switch 1 to switch 4?
So this PC will generate traffic, right? It will forward to switch 4. Switch 4 will add tag number of VLAN 20. Again, switch 3 will remove tag number on this interface. Again, switch 3 will add tag number, right, of VLAN 20. Again, switch 2 will remove tag number on this switch. Also, and then if switch need to forward it to switch number 1, again it will add tag number here of VLAN 20.
Here VLAN 20 is there, na switch 2.
Yes, so if you are pinging to this user, then definitely switch will forward to traffic to this user. If you are pinging to this user, then switch 2 will forward traffic to switch 1.
Along the tag number, it will carry something. What is that? What that is?
Along with actual traffic, it will add tag number on the trunk link. Let's say this user is pinging this user, right? This user, right? So traffic is ICMP echo request. After that, we have IPv4 header. Then we have layer 2 header, Ethernet header, right? And then switch will add one tag number here, right? This is traffic of user. User have generated this traffic, right? It will forward to switch 4, and switch 4 will add one tag number over here at the end. So whenever switch 3 will receive the frame or traffic, first it will check tag number. On the basis of that, switch will process the traffic. So the switch is not going to open Ethernet header na, or IP header na. Switch will check only tag number. On the basis of tagging, switch will forward traffic.
For example, switch 4 user, VLAN 20 user, pick the data from the switch 1 VLAN 20 user, some file or
Okay.
some whatever.
Okay.
Then how will it happen?
Switch will receive this actual information. Switch will not receive this tag information. Switch will receive this actual information. PC will receive this actual information. PC will add Ethernet header. It will check destination MAC. In two scenarios, it will accept the packet if destination MAC is broadcast or the MAC address of this PC. Then only it will accept the traffic. Then it will check type field. In the type field, there will be information of IPv4. So it will hand over to IP protocol. IP protocol will check IP header. Again, inside the IP header, it will check destination IP address, destination IP. In two scenarios, this PC will accept the packet if destination IP is broadcast or destination IP is the IP address of this PC. Then in the IP protocol, there is one field called protocol field. It will check protocol value. According to that, in protocol value, information will be 1, protocol number will be 1. That means it is ICMP protocol, ICMP traffic. So it will hand over the actual ICMP traffic to ICMP protocol. PC will not receive tag number, na. PC will not receive tag. So it will remove tagging once it will receive traffic on the trunk link. What I am saying, whenever switch need to forward traffic on trunk link, it will add the tag, and on switch will receive the traffic on trunk link, first it will remove the tag.
And one more scenario from switch 1 to switch 2, VLAN 20, both VLANs 20s are not able to communicate because we are restricted. VLAN 20 to VLAN 20 from switch 1 to switch 2.
Okay.
But in switch 4, VLAN 20 is there. We have to communicate these two VLANs to switch 4.
Okay. So if you have not allow VLAN 20 on this trunk link, then definitely VLAN 20 user from switch 1 cannot communicate with this user, with the user who is present on VLAN, on switch number 4. But if you have, let's say, configure access control list or any other filtering between VLAN 20, between this VLAN 20 user and this VLAN user, so these two user cannot communicate with each other, but these two user can communicate with this user. So it depends how you have restricted VLAN 20 user on switches.
Through ACL.
Yes, so then through ACL, if you have restricted, then these two user cannot communicate with each other, but these two user can communicate with this user. Anything else?
Yeah, last one. If we place this one more router in between the switch 2 and switch 3.
One router here.
Yeah.
Like this.
No. Switch 2 and switch 3 in between.
Okay, like this.
Yes.
Like this.
Yes.
Okay. Now.
But it is not the WAN router. It is the LAN router.
Okay.
Then how we configure this scenario?
Why you have connected one router here between switch 2 and switch 3?
And this router is connected some other network later, some through some port. It will connect it to some other firewall, something that is different.
Let's say ISP.
Yeah.
Okay. So
Oh.
here you will configure one IP address, here you will configure one IP address, here you will configure on one IP address, and here on this interface you will configure one IP, here you will configure one IP. You can run routing protocol between these devices. But if these are layer 2 switch, then you cannot connect router. I think this should not be my scenario. This is an incorrect design. Whenever you need to design network, that's why we have a separate course, network designing, right? In that course you learn how we should design network. We have one architecture from Cisco, so you should follow that architecture to design network, right? Complete network design divided into 3 part: core layer, distribution layer, and access layer. So this is access layer, brother, and here you are directly connecting core layer to access layer, right? Which is not possible. You have one distribution layer between core and access. So this is, I'm not getting actually your scenario why you are connecting one router here, and then this router is connected with, you are saying, firewall, and then to ISP or maybe to another device. This is incorrect scenario.
Sir, can you explain VTP modes?
We have 3 modes in VTP: server, client, and transparent. On server mode, you can create VLAN, you can delete VLAN, you can modify VLAN. On client mode, you are not allowed to create VLAN, you are not allowed to delete VLAN, you are not allowed to modify VLAN, right? On transparent mode, again, you can create VLAN, you can delete VLAN, right? You can modify VLAN. Okay, now what is the difference between transparent mode and client mode and server mode, right? So transparent mode switch is a special type of switch in networking. Actually, this switch, transparent mode switch, if you want to separate one switch from VTP domain, you can configure transparent mode switch, transparent mode to that switch. Let's say what I want, that my switch 3 should not update their VLAN database with VTP. Means if I am creating VLAN 100 on switch number 1, right, switch 2 should create that VLAN, right, switch 4 should create that VLAN, but switch 3 should not create that VLAN, right. That means switch 3 should be able to receive message of VTP and propagate message of VTP to their neighbor, but they should not update their database. For that scenario we have transparent mode switch, right. If you don't want to allow user to configure VLAN on this switch, let's say, right, what I want here, let's say my L1 engineers are connected, right, L1 engineers are connected, fresher engineers are connected, so by mistaken they can run no VLAN 10 command, right. So what I want, whatever user are there on this switch, they should be not able to create VLAN here, right. That means on this switch, if you want to create VLAN, so you can create VLAN through VTP. Like if switch 1 will propagate some VLAN to switch number 2, definitely it will update their database, but manually we are not allowed to create VLAN, delete VLAN and modify VLAN over here.
So that switch 2 we should put in that client mode, right?
Yes, this switch should be in client mode, this switch should be in transparent mode, and this switch can be also in client mode, and this switch is, let's say, on server mode. So on this switch, whatever VLAN I will create, that VLAN will be propagated to switch number 2 and switch number 4. Let's say I have a scenario. Here I have one switch, here switch 1, switch 2, switch 3. Here we have some servers, right, and outside users are accessing this server. There are many servers, and these servers are in, let's say, in VLAN 10, right. These servers are in VLAN 10. This switch is connected with one router, and through this router is connected with let's say ISP. Getting my point, right. Here I have L1 engineer, as I told you, any guys who should be not able to create VLANs, okay. And here we have expert guys, those guys are managing network, so these guys should be able to manage VLANs on switch edge. So this switch should be in server mode, this switch should be in client mode, and this switch should be in which mode, transparent mode, so that even if someone will delete VLAN 10, right, because as I told you, here we have servers, and outside user are accessing this server. Let's say this is DHCP server, outside users are getting IP address from this DHCP server. So what I want, from this switch, if someone will delete VLAN 10, right, that means my outside users are not able to access server, now server are down. So this switch should be in transparent mode, so that no one can modify VLAN information here through VTP, right. So now this switch is, no, you can say this switch is still in VTP domain, but is not updating their database through VTP messages. Clear? So if I will configure switch 2 as client mode, see, on switch number 2 I'm going to run one command, config t VTP mode client. And now if I will try to create one VLAN, let's say VLAN 101, what it's saying, VTP VLAN configuration not allowed when device is in client mode, right. But if I want to create VLAN 101 on this switch, I can create that VLAN on server mode, like on switch number 1. If I will create VLAN 101 on this switch, VLAN 101, automatically this switch is switch 2 on switch 1, on switch 1, because this switch is in server mode, so here I can create VLAN 101, right. So automatically on switch number 2 you can verify VLAN 101 is created. So VLAN brief, right. And let's say switch 3 is my transparent mode switch. Switch 3 is transparent switch. right? Here you can create any VLAN, right? But that VLAN will be not propagated in VTP domain, so you can verify it on any other switch, like on switch number 1. So VLAN brief, you can see VLAN 11 is not created over here, right? And now on switch number 1, whatever VLAN I will create, let's say VLAN 111, right? Now you can see on switch number 2, switch number 2 will update their database. Here we have VLAN 111. Switch number 3 will update their database or not? No, because this switch is transparent mode switch, but it will propagate the VTP message to switch number 4. Because of that, on switch number 4 again we can verify. Okay, now tomorrow I will start STP protocol. STP, spanning tree protocol. Okay, so by default you can see a spanning tree protocol is also running on switches. By default it is enabled, only we need to learn it. Okay, all VLAN is removed from switch number 1. So VLAN brief, all VLAN is removed from switch number 2 also, switch number 3. So VLAN brief, all VLAN is removed from here also, and on switch number 4. So VLAN brief, you can see now spanning tree is working only for VLAN 1. Okay, so tomorrow we will see a spanning tree protocol.
So server and client will be having the same VLANs. Transparent mode will have the VLAN created in that particular switch.
Manually we have to create VLAN on transparent mode switch.